Good morning, good afternoon. I'm Eric Sandberg, and I would like to give you a brief update, a 5G overview, and about the RAN trends last part of 2022. So this is just a highlight. The 5G market taken from GSA continue to grow. 500 operators in 155 countries have now invested in 5G networks. 228 have launched commercially 5G, and 111 are investing in 5G standalone. And about 35 of these operators have launched 5G standalone. Private mobile network is growing, both 4G and 5G, and more devices is supporting 5G NR. Massive MIMO is the dominant technology in the C-band because it has far the best TCO for capacity increase over the existing site and existing grid. 5G standalone deployment has been slow. So is 5G monetization. It still continue to be slow, driven by mainstream service like video, and this drives actually the capacity need. Open RAN is a very strong trend, but maybe virtualized RAN is more than open RAN. We'll come to that later. Virtualization in general continue to be strong, and from virtual network functions to container network functions and cloud native. Mobile edge computing and edge computing in general continue to be a key driver for ultra reliable and low latency services. And the telco to techno transformation is ongoing, but still slow. And with that, AI and ML continue to improve, especially around the RAN intelligent controller, but also on higher level with service management and orchestration. Okay, this is the agenda. First, a little bit introduction, market update, and then about 5G NR Massive MIMO, 5G sync, and I cover non-standalone and standalone, Open RAN and TIP, Telecom Infrastructure Project, virtualization in general and open source, and a couple of words of edge computing and AI ML. So this is just to show that where we are in the process of 3GPP. Release 17 is the latest release right now, and release 18 5G Advanced has started in last year. And on the Gartner hype curve, we will see network automation and private LTE coming down from the top. Open RAN is also getting more and more traction. Network as a service, vRAN, and network slicing. On the upper part, we have the radio intelligent RAN intelligent controller. We have edge platform, private 5G, and mobile edge computing, for example. Going into the market update, 5G, where are we? We are just reached 1 billion subscriptions last year, which is an impressive number. As I said, 5G SA deployment has been launched in 35 of 35 operators, and the release 16 and 17 have been adding new capabilities and new services is emerging. I think I covered this numbers already, but as you can see, the launched and invested number of operators is now counted up to 500 by October last year. So just an overview of TDD versus FDD, which is important for sync. The most common frequency band for 5G is actually 3.5 or the C band, where massive MIMO is being deployed, and where TDD actually is dominating. Also on millimeter wave, but it's not that mature yet, and it's mainly for local coverage, which uses TDD. On the lower frequency band, we have still FDD frequency arrangement. And another difference from 5G to compared to 4G is, of course, the many more different applications, such as cloud gaming, augmented reality, and massive IoT. Even if IoT is not especially 5G related, really, it's been around for many years. And the new thing with 5G actually is the ultra reliable and low latency. It is ongoing, and we have a lot of features that in the radio that covers low latency applications, as well as high reliability features. And if you see, mobile broadband is the most dominating today, and we have the IoT part, which has been going on for a while, which will continue. But the new pillar in 5G is actually the ultra reliable and low latency services, and that one requires actually 5G standalone, which I come to later. But new radio has new features to address both ultra reliable and low latency communication services. There is a problem according to this survey. What are the biggest drivers of adopting 5G in your organization? And of course, high priority is security needs and mobility needs, cost savings, bandwidth needs. But on fifth place, we have latency needs. And then this survey indicates that we are not really ready for low latency services today. That's my analysis. But according to other sources, telecom professionals now see low latency as and standalone as the future of 5G, really. So for this survey, you can see from today, low latency on third place is then in 3 years going to be maybe the most important priority of greatest commercial significance. Looking at the frequency bands, as I said, C band is the dominating band among 5G devices as well. So N78 and N77 is actually both C band, and these are on top among devices. This also shows that how many number of devices, about more than 1,000 devices are using TDD on 3.5 and TDD on 2.5 as well, which is N41. So these are the two top for TDD devices on the market right now. And Massive MIMO is also dominating in C-band. As you can see, these numbers from different operators, among them, such as 63%, 88%, and 83% are Massive MIMO equipment, and very few which actually are standardized RUs. 5G comp is actually an important feature to achieve ultra reliability. So what you do is that you compare, or you transmit simultaneously, coherently between different access points or base stations. And this one requires actually a relative time error of down to 65 nanoseconds, which shows that in the future, accurate synchronization is really, really important. And if we look at new mission critical services, we have aviation and public safety services, industrial automation, autonomous vehicles, remote medicine, robotics, and smart grid and energy as maybe coming new applications coming in the future, all rely on low latency, high reliability, and high availability. And this just shows the RAN features in sync requirements, where we actually for TDD, Massive MIMO is the key to future capacity, more important than FDD. And TDD is also more flexible when it comes to uplink, downlink traffic ratio. So the requirement we have on TDD is 1.5 microseconds, or even less, actually, 1 microsecond. So this shows that the capacity band is really the C band for TDD, compared to the lower bands where you use FDD then for coverage instead. Coming to 5G sync and standalone. As you know, currently full-time support PTP is needed in every node, and this is just showing some examples, but full-time support PTP actually do not scale in a cost-effective way. So this shows that you basically need GNSS at every single site in the network, or other solutions where you have PTP boundary clocks or edge grandmasters in the network. One thing with 5G is the slicing. That means that you have a specific SLA or service level agreement connected to a different kind of services. So this is just to show the latency numbers for different kind of services. So for IoT or massive machine type communication, typically you have 15 millisecond one-way delay. For mobile broadband, 4 millisecond one-way delay, and for ultra reliable and low latency, it's 0.5 milliseconds one-way delay. These are the different slices in the network. So currently, with flexible networks, you need to have a control plane very close to the user in order to lower the latency. And typically for machine type communication, it really doesn't matter. It's not a real time application, for example, with a water meter or something like that. And below here you see the percentage of transport delay comparison between the different, the three 5G pillars, so to say, machine type communication, mobile broadband, and the lowest part of them is then ultra reliable low latency communication, where you have the strongest need for low latency and high accuracy. One thing I need to mention is also that there is something called TSN. It's based on general PTP or IEEE 802.1 AS. But when you look at the architecture, there is a need for an adapter at both ends of the 5G network. So this is our core network inside here, and this is if you should have low latency service over the air interface to a device. So then you need some kind of device side TSN translator, and on a network side you need a network side TSN translator. And perhaps this is not a good way and will be problematic in the future. So maybe we have a future here as well to deliver sync all the way to the user application. This is just to show what I mentioned, that user plane functionality and the control plane needs to be very close to the base station if you are running reliable and low latency service. And the opposite with massive IoT, where basically everything can remain in the core. And this is just a table of different service models for different operators. There is no general agreement, you can say, or trend. So different MNOs have different strategies, and business model is really not clear how you deliver new services. For example, it's just connectivity, or is it wholesale for multi-tenancy, or is it more edge computing services, or turnkey 5G, or private custom solutions. Different operators are testing different versions here. And telcos are actually struggling with new SLA-based services on application level. But as you can see, latency is perhaps the number one SLA that you really can charge for if you can promise, or if you can find a business opportunity in that. Statements from British Telecom: the end state for us is offering end-to-end solution. Traditional telcos won't be good at the application layer, but this needs to change and is changing. So what is then 5G SA? It's standalone, it's a new core, but you also need support from the phone device and the phone. So actually today, 61% of the phones are supporting 5G SA or 5G standalone. And this is the table of the 36 or 35 number changes a little bit between the service, but these are the operators that have launched 5G and could be the one that we should approach also for 5G sync. Just to explain, NSA is when you have non-standalone, which means that you have the 4G core, and 5G standalone is when you have a 5G core. So yeah, I think I skipped this slide. I already mentioned that 112 operators in 52 have been investing in 5G SA, and 37 operators are launched. And very interesting area is the adoption of private mobile network. It's not purely 5G, so this is started already in 4G. So as you can see, there are almost 1,000 networks that is actually private networks, especially in China and US, also in Germany. Manufacturing is one of the biggest application, and I will have a look at that in a while. So if we look at manufacturing, the forecast is that that will be maybe 90% of the different use cases in 2029, and a total access market of 16 billion US dollars. So manufacturing, education, mining, power utilities, and defense and peacekeeping are the top applications here. MNOs want to add more value, so staying with connectivity is maybe not the future way, but if we see on the market cap here, connectivity has very little market cap compared to, for example, doing user devices, or even being on social media or other so-called gig economy services. So MNOs and CSPs, communication service providers, and mobile networks operators want to add value. They want to climb in the value chain and not stay with connectivity. And actually 30% do have no plans on standalone, which means that maybe they just want to stay as bit pipe providers, but most of them would like to grow with new business opportunities. And AI and ML is maybe the key driver for going with new services. And just an outline of the 5G progress from British Telecom. They have more than 2 million 5G SIM cards since the mid 2021, but there is limited SA capable devices in the UK. They plan 10,000 plus new and upgraded sites the coming years, multiple 5G private network, but better than first. They want to know what they're doing, and they're not very aggressive on new stuff. Another vendor, mobile operator Telenor, have been using multi-vendor SA, which is possible then on a cloud native core, mobile core. So one idea is to bring in new third-party applications on the network, so to say. And this is just an example of Telenor that is pushing the boundaries of connectivity by introducing the world's most diverse multi-vendor 5G standalone solution today. And there is a couple of videos that I added here that is available in the presentation mode. And this is an stopper from Singtel and for high-speed streaming experience and lag-free. So for 9.99 Singapore dollar for a week, a customer can enjoy the race in their 5G services, lag-free, high-speed streaming experience. Very close to our media business, I would say, but there is no Nimbra involved and in this network yet, as I understand. So what do you have to do when you go from NSA to SA? Yes, you go basically to cloud native solutions and from virtualization, which increase the complexity but it also increase the capabilities. And what you want to do is, of course, to grow value. If we look at the challenges, cloudification increases complexity as well with multi-vendor, but actually multi-vendor is what more than 50% is looking into to use in the 5G core. As an example, the traditional release plan is maybe one or two per year. But if you look at the cloud native, you have perhaps 3 vendors that is using the CNFs, and then you get very regular releases and another release plan for other parts of the network. And this increases the testing complexity by in this case 10 to 50 times, which actually says that you need to go for automation if this is going to be cost efficient. Okay, I continue with Open RAN and telecom infrastructure project tip. So this is actually very much about multi-vendor. The background is, of course, that Ericsson and Nokia is now the two main vendors, and operators want to have a vendor diversity in the future. So Open RAN in early 2022 actually was forecasted to be around 10 to 15% by 26, and it was actually revised upward to 15 to 20% now in January. So and Dell'Oro is a quite reliable source, so it's really looking good for Open RAN. The vRAN, I would say, or Open RAN is not clear, but we'll see. TIP, another organization, is actually having the strategy to disaggregate the complete network from 5G core all the way to RAN, including transport, data centers, and OSS operating system and business support systems. So in this investigation, you see the importance of what to disaggregate actually. The most important one for us is the Open RAN, but it's not included in this survey. In this case, Samsung is actually number one. If you so far you can call it the Open vRAN leader. Samsung won the TIP RFI contest in November 2019. They scored most of the score from the RFI, and is now gaining market share in the whole world, mainly in US and Asia, I would say, right now. But it's also open up for many other suppliers as well, like Mavenir, Parallel Wireless, Rakuten Symphony, which is a merger of Rakuten and Altiostar and made into a supplier rather than an operator. And then you have NEC, Fujitsu, Juniper. And on the hardware side or accelerator side, you have Qualcomm and Xilinx, and of course Intel is very strong in this area as well, pushed by, for example, companies like Meta. So Samsung, Fujitsu, NEC, and Mavenir are the top 4 Open RAN vendors. One drawback with Open RAN is that this option split, which makes this interface open on the front haul, it's called option 72X. It's an eCPRI version. The interface is called CPRI, and now with it's extended, so it's called extended CPRI version. But it's not really optimized for massive MIMO. The overall specification is ongoing, so work is going on to make massive MIMO feasible also with Open RAN. It's a very big drawback currently, but maybe in a year or two, massive MIMO will also be possible with Open RAN lit options. And for O-RAN or Open RAN, they have also defined 4 different sync options, where number 1 is just GPS with sync E as backup, purely from the DU to the RU. 2, 3, and 4 actually using some kind of switching for the front haul, which I think that is a very unlikely scenario. Point to point will be the dominating front haul for many years to come. So this is just to show some Open RAN site deployment with the GPS, PTP, and Sync E. Some parts don't have this cell site router, then you need to go directly into the DU at site. And actually, this is from Telefonica, and actually they claim that network-based synchronization is deemed as the best and most future-proof option because it avoids potential points of failure like GNSS receiver or daisy chain connection of DUs. However, it requires full network support of PTP and can therefore be applicable only in a limited set of scenarios, which we have seen some operators already experienced. And of course, that gives huge opportunities for us in Net Insight. 22 was meant to be the breakthrough for Open RAN, but what really happened? Yes, it was. This shows the global deployment of CRAN, vRAN, and Open RAN, and as you can see, not that many. Only 3 out of 8 was going live, and so Open RAN is arguably not essential for most of the 5G use case as we expect to support yet. Macro networks rollout have been done by Deutsche Telekom, Orange, Telefonica, and Vodafone, but these are pilots and continue as pilots. We have these vRAN deployments going on which is maybe not Open RAN, but virtualization of RAN. We have Rakuten, KDDI, Telefonica, and by Nokia in Germany. We have Vodafone and Samsung in UK, and we have Samsung in Verizon, Samsung in Dish as well, and actually Ericsson at Verizon. So speculation is if perhaps vRAN is more important than Open RAN going forward in the future. And one important breakthrough is when Qualcomm released the hardware accelerator in October last year with actually massive MIMO 64T or 64R support. So this could be the major vRAN event actually in 2022 and could possibly grow the ecosystem further. The RAN is responsible for 1 to 2% of global energy consumption. So running with COTS hardware in volumes is not attractive for operators, and this could be the reason for that vRAN has not been scaling to high volumes yet. You need hardware accelerators to bring down the energy consumption in your network. And one thing, this is Intel, of course, in the DU, they are now working with the synchronization solution based on PDP and 1588 and Sync E, and which we know we could perhaps do as well or do better to transfer the time to these kind of boards, enabling then further development or further deployment of Open RAN. This is another example of Open RAN architecture where they use white box radio units together with the network interface cards and accelerators in a project called Open Compute Project. Interoperability is still the biggest challenge for Open RAN. So multi-vendor comes with a drawback that you have to put it together. Someone said that we have to have one neck to choke, and it's obvious that you have to find a right value chain to avoid just another lock-in of operators or vendors. So what happened is that you get so-called pre-integrated vRAN stacks, and you create echo islands, you can say, instead of multi-vendors. So this is just to show one type where Fujitsu, Wind River, NVIDIA is part of one ecosystem working together, Red Hat and Xilinx and other, Red Hat and Qualcomm and VMware and Intel, for example, together with Mavenir, a third type. So it's much more likely that we will see vRAN, but coming in different flavor like this. One important thing with the Open RAN is actually the RIC, which enables then an ecosystem of applications by third-party vendors based on open source actually. And when it comes to automation, this is actually key to major OpEx savings. So the RIC is therefore one of the most important network element that is coming with with virtualization and open interfaces. So this is an example of Verizon that going from predefined services to automated orchestration and all the way then to automated management based on cloud solutions. And energy saving, this is not an example of energy saving with RIC implementation. So to switch carriers off and on in a cell is actually one of the most largest potential to save OpEx for an operator. But energy saving features has been around for more than 10 years in a so-called SON, self-organized network, specified a long time ago. So this is really nothing new, but still it could be a good feature to have in the RIC. I would say that another interesting company is Cohere, and Cohere is also a player that pops up when you have open interfaces. So suddenly it's possible for a company like this to actually be able to use innovative algorithms for multi-user MIMO scheduling. This company then adds software to the network and could optimize the use of multi-user MIMO. And I won't go into the details here, but they could possibly benefit from more accurate and reliable sync. Today, they work on near real-time RAN intelligent controller and non-real-time RAN intelligent controller. But if we're talking real-time, then you need also to have access to good synchronization. But if we look at the performance so far, they show an improvement of 100% gain in using their, which is a lot, using their application in the RIC. So this is impressive numbers from a software supplier. In the RIC, you can also have conflicts, of course, between different applications. So you have to be the drawback here is that you have to solve conflicts between different applications. So this is still something that maybe O-RAN is working on, how you release or mitigate conflicts between different applications on the RAN if you open up for third party. One news is that Open RAN is now being developed also within the Linux Foundation. So they are doing the open source code for Open RAN, and they recently announced that they have an Open RAN simulation platform available from October last year. And that opens up for open source landscape. So many different companies could actually be part of this and use the type of delivering telco software. This is an example from the Swedish company called Radtonics. It actually uses an open source core software to deliver services to public and private cloud, private network in Sweden. Yeah, not all MNOs have the skill set to navigate in this environment of multiple software suppliers. So we'll see if this is going to happen or not, but it's a lot of buzz around this right now. 10 years ago, an operator would not even touch open source, but today open source is maybe one of the most cost-efficient way to move forward in 5G. So a couple of words about general virtualization. This is just to show that Google Cloud is working on this as well, delivering platforms for operators so that basically they can host or they can actually use Google Cloud for their network instead of proprietary network. And the drivers for cloud native solutions is actually faster time to market and new services, of course, and using containers and microservices, continuous integration, CI/CD, decouple application from infrastructure, and to be able to have an automated life cycle management possibilities, increased efficiency. Not all of this has been proven yet, but as core becomes virtualized, RAN has also become the most costly in part. So if you see maybe earlier core and RAN was 50-50, today you see that the capex of RAN is far more costly than core. So operators are hoping that RAN will go this way as well to bring down the cost of their network. So cloud evolution continues, but I would say it's not growing fast, but it's going there. There is an evolution. It's going to happen, but it's not happening very fast. So as you see, network functions are run as CNFs, 14% of them today, maybe up to 34% in 27. So it's not that you change your network over one night. It's an evolution. Rakuten is maybe one of the most important or the driver for virtualized RAN. Perhaps only for greenfields. It's not been very successful among brownfield operators yet. They have recently founded a new lab in UK in March last year. They still have red figures, but and was expected to build a network very fast and very cost efficient. But unfortunately, they launched in 2018 and they still only have 4% market share. So obviously they have not gained that many subscribers yet. They claim that they build a network with 30% lower capex and actually 40% lower opex because of automation. But even COTS are not for free. I have checked a couple of hardware devices here, and it's very difficult to see or to prove if they actually have can claim that this 30% is achieved. But their plan is to build the mobile as a software, totally softwareized, and automation is in their plan. And as I said, they claim huge reduction in TCO. Dish, which is the other American fourth operator, has started last year actually with then welcome developers to its virtualized 5G network. So they have possibility then to use application programming in the interface to allow them to experiment on its 5G network platform. So exciting happening here. Coming into edge computing, latency is the key driver, and that is also, you can say, it's the currency of the edge. Looking at different kind of latency down to 2 millisecond, 10 millisecond on edge application, and data center regional, perhaps 20 millisecond compared to centralized cloud data centers today is where you have 100 millisecond. You want to bring content or services closer to the customer. And this is a couple of latency requirements from 3GPP. As you can see, there are in the millisecond and millisecond range from 5 millisecond up to 10, 20, and 25, depending on where in the network you have your so-called edge. So, but what you can say is that the most ambitious edge requirement won't materialize overnight. Rather, there will be a slow ramp up that gradually see edge sites moving closer to user as apps eventually require it. I think that's a good statement. Another picture from Google showing the pre-2020 where you have cloud connectivity via core, and post 2020 where connectivity is moving closer to the edge, and you have hybrid cloud and mid backhaul for optimizing latency here. And as you can see, AWS, Amazon, Google, and Microsoft is driver also in this. We're talking enterprise business. And this is one example with urban traffic management with ruggedized edge, actually also including AI roadside unit where you monitor the traffic and you can make conclusion using the video system and control system for light control here, and optimize the traffic, of course. And also Uniper view the metro is a new edge, big growth potential in this area. Verizon also working a lot on this in the US. A couple of announcements from Verizon in US. And TELUS in Canada working with Red Hat, both hybrid private 5G and public 5G. Enabled by Red Hat, for example, which indicates that this is also a lot of open source in this one. And cloud versus edge, what's the difference? As I said, yes, the key driver is the latency. Cloud computing in general is high latency. Edge computing is supposed to be low latency. Another example from Elisa in Finland. They claim that with AI analytics, they can actually have a revenue of another 200 to 300 euro per month, and camera in certain application. Parking info, people flow in retail, inventory, automated inventory imports, and this is from a container. Another example from our broadcast is that broadcast part is that you can also use mobile cameras now with 5G. So that's also something that's going on right now, testing of that. This is an example from Germany, where you have AI cameras following a game of football, actually in real time and automatic. You don't even need a cameraman. So these cameras are following what's going on in the field or in the football field. Smart stadiums is another thing that pops up. Smart spectrum view, that you can actually monitor perhaps your favorite player, and you can have special camera on that guy. China is the biggest vendor, the biggest edge computer user, actually a mobile user. They have a total of I would say 20,000 contracted edge services, and totally completed for China is 5,000. So this is impressive number. This is one example with 5G edge aware network, where they have 8K cameras on 5G connected robots for quality inspections at very high pace, 4,000 meters per minute. They can do inspection with a robot sending 8K video uplink. And this is just a future picture of how it could look with different kind of players in different field, but for different application and in our society. Vision for 6G perhaps. Telco's role in this is not very clear, actually. They have not been that successful really when it comes to deployment of new services. Connectivity is a small part of the overall solution, and it's actually unclear whether telcos are needed to deploy private 5G facing their challenges. Maybe I repeat, manufacturing, mining, oil and gas, and ports are the high-level deployments in private 5G so far. And the private 5G ecosystem is complex. Vendors are looking to build holistic solution, must work across it, and maybe this is the difficulties for an operator to work on with so many different players in different areas. But one important player is Amazon, and they announced this, that they announced private 5G solutions together with Dish, actually, and you can get started with your private 5G at a very low introduction cost. And many operators, they investigate the business model of this, as I said, with dedicated edge as a service, system integration, do it yourself, or B2B2X solutions, and having and do everything from end-to-end customer application. For network functions, edge is having poses some critical requirements, as I mention it again, that real-time processing, signal and synchronization requirements are crucial for edge. services. But, and this is just to show operators, they spend very little on R&D. So maybe this is why I am reluctant to believe that they will succeed in this market. You have to put more money in R&D, I would say, to be successful. If you compare Facebook and Google and Microsoft and Ericsson, Huawei and Nokia compared to the operators spending, it's a huge gap. And that is also shown on the market capitalization. If you look at the market cap for these companies, Facebook, Apple, Netflix, and Google, revenue and market cap compared to European telcos, for example, it's very low. Yes, just to show that AT&T is, of course, working in the same direction as Dish with third-party platforms. And another example of different operators working on different areas with distributed core, with network edge, and with private networks. So you can see it's a lot of initiatives, and the network architecture is actually have to be very flexible to support all these new services. But they have accelerated their collaboration with hyperscalers in the past. So looking 1 year back, they've increased the collaboration with Microsoft, Google, and Amazon. CSP is actually voted for the top cloud partner, and Amazon came out first, followed by Microsoft and Google. Couple of words of AI, artificial intelligence, and machine learning. This shows Mavenir that uses AI and analytics in their solution portfolio. So they use it for their network to optimize the network performance, enable fast response, and achieve, of course, cost savings. So AI together with the RIC is an important part of a future network because it's so complicated and a lot of services. And this is just a few applications with AI ML. And looking at this picture from Red Hat, you can see that in the applications then with hyperscalers inside these applications and these data platform, you can see basically AI ML on all different layers, not only on users, but in the network you have different business applications with AI ML. So it's gonna be used basically everywhere in the network. I would like to mention the elephant in the room is indoor traffic. 80 to 85% is indoor traffic. It's not addressed with 5G. So when you look going forward, 6G actually need to be designed with indoor use and shared neutral model as primary. This is kind of, I think it's something that is really missed in 5G. And if we're looking forward ahead to 6G around 2030, we're looking into a world of intelligent, but we started with 5.5G. Everything would be connected. So I think, yeah, it's on the same road as we started right now. Let's see what that happen in 2030 then, if we are around. Okay. Thank you very much for listening in to this. Hope you enjoyed it. I have, if you contact me, I have slides that I can send to you as well, so you can flip through yourself. Okay. Bye for now. Thank you.